Alright, chapter 4.3 is solving quadratic equations by factoring. Depending on your experience with factoring, this section could take some time. If you have issues with section, you should understand your issue more than likely just comes from a weakness in factoring, not the solving part, because typically this part and that part being your two options, this is the tough part, that's actually the easy part. So if you're having an issue factoring, that is what's going to cause your issues, not the solving portion. So what we're going to do is just start from the end and then kind of go from that. So factoring is one of those weird things where if I teach it to you from the beginning, it helps, but it's kind of intimidating, whereas if I show it to you from the end and give you a little bit of confidence, it should help you out. So we're going to start off on the solve portion. When it says solve, you have something times something else equals 0. And typically the rule for 0 or anything multiplying to be 0, again, you can kind of learn this, but again, it's common sense. If I took 6 times 0, it's 0. If I took 0 times 19, it's 0. So as long as one of those numbers is 0, you're going to get the answer of 0. So what we do when we solve, once we have it packaged up as something times something else equals 0, is we say that this first part must equal 0, or this second part must equal 0. We then solve each part to get two answers. And those two answers represent the solution to the problem. So what we are doing is factoring puts it into this form, or factoring will put it into this form. Once we have it in this form, you will take all of your factors, set them equal to 0, and get whatever solutions are there. Sometimes you can have more than two factors, so what you would do here is something times something else, set all three factors, or however many factors you have, equal to 0. And again, from there, this one's already solved. That's solved now, and again, your algebra portion should be easy enough. It's just a matter of making sure you understand how to finish it off. So this is what we're going to wrap everything up with. I don't know if I'll actually finish them up because I have a lot of pages to get through, but that is how you actually solve a factored equation. So again, everything here has been factored. Hopefully you copied those two, because those will help you later on when you see what we're going to be doing later. The rule of factoring, or solving by factoring, is simple. The first thing you do is factor the expression. The second thing you do, as I said, is set all factors equal to 0 and solve. As I said, if you had an issue with factoring, this is where your issue is going to be, because if you don't know how to factor, you're going to have issues. It's just a natural thing, and that's really where the practice is, and why I kind of slowed it down to 2 sections per day, or per week, because I did not want you to have to rush through this, especially since we have time to do it. You might have to watch this video again once you have the factoring process under control. Like other things, like some movies that you might see, it makes more sense after you see it, because again, the second time you watch it, you'll have certain things in your brain and it'll stick better. But let's just go ahead and get to it, because again, we are here to learn that and get to the point. There are three main types of factoring. The first two are pretty easy, but they are also easily confused. Just remember, you should have seen these before, so I'll try to find extra links and put them on the page for actual lessons on factoring, but again, I think this should cover it. And if it doesn't, and they're not up, just email me, and I will gladly email me and say, hey, do you have the extra links for the factoring lessons, and I can find those on my old page and get them to you. Although it is going to be another 10 to 15 minute lesson of factoring, but that's that. We learned difference of a square. Again, this was in Algebra 135, in which this is 3 times 3, that's x times x, that's 5 times 5, and what we learned was this is 3x plus 5 and 3x minus 5. Again, that was something you learned last year in Algebra 1. You had 16x squared minus 81. 16 is 4 times 4, x times x, 9 times 9, so it ends up as 4x plus 9 and 4x minus 9. That is your difference of a square. So again, hopefully you copy those and put difference of a square so you remember that if you see it. And the other one is GCF. The difference between these two, they look similar because they both have two terms, but the difference in this is that everything is a perfect square. 3 times 3, x times x, 5 times 5. Yes, that's 3 times 3, that's x times x, but nothing multiplies by itself to be 18, and there's just a random x here. And so in this case, it's greatest common factor. So what you do is you say, what's the biggest number I can take out of 9 and 18, which is 9. And if this has 2 x's and 1 x, the most you can take off is 1. Again, you saw this last year. Please make sure you ask for help if you need it, because if you don't, all this stuff is going to eventually hurt you. Plus, we're going to be using GCF a lot anyway. But again, the biggest number I can take out of 9 and 18 is 9. The most x's I can take is 1 because they have 1 in common. You then do 9 divided by 9 is 1, which we don't write unless we have to. If I had 2x and took 1 off, I'm left with 1. Copy the sign. 18 divided by 9 is 2. I had an x, I took it off, it's gone. That is it. It is the anti-distributive property, because if I was to distribute, this times this is 9x squared, this times this is 18x, and that is how you check your work. Now I did this on purpose because sometimes the numbers get big, and you'll want to kind of write this down or practice this for yourself with your calculator. But how do you find the GCF of two ugly numbers? I usually take the two numbers and put them in fraction form, and I believe you have one of those on your computer or on the online calculator where you can put 168 over 312. What your calculator does is it figures out the biggest number that can divide, which is hidden, and it gives us the reduced fraction. So what we're looking for is, what did I divide 168 by to make it 7? Also, what did I divide 312 by to make it 13? I usually just do the top, so 168 divided by 7 means that the hidden number in here is 24, which means the biggest number I can take off is 24. This has 3 x's, that has 2. I'm going to take off 2, and then again we go from there. So let me show you that again. If I had a number like 608 and let's say 712, it's going to reduce the fraction by dividing by something we don't know, so all you have to do is divide this number by the other top number, and it tells you pretty much what that hidden GCF is, because both of these are being divided by 8. 712 divided by 89 is also 8. So again, that GCF number is 8, so that's how you get that number there. Other than that, 168 divided by 24 is 7, so it should be 7 left over. If I had 3 x's and took 2 off, there's 1 left. Copy the sign. 312 divided by 24 is 13. I had 2 x's, took both of them off, and I am done. GCF is the more complex of the two, but you're going to be using this a lot. So again, make sure you communicate, because if you don't know how to do GCF factoring, you are definitely going to have an issue with the process that we are doing. But this represents the two of the main types of factoring that we're working with, as we will slowly work our way into the actual third part. So the type of factoring process that will be reviewed completely, which is the third one, if you know another way to do it 100% of the time, feel free to use it. So again, if your teacher or somebody else taught you how to do it in a way that works for you 100% of the time, feel free to use it. I am not the teacher who says you have to use my method. I will say that if you're not going to use my method, you might want to make sure you have mastered your own method, because otherwise, you're still going to get not so good of a grade. So other than that, the process I teach has 4 steps. First, what we're going to do is translate into a combination. Again, don't worry about what the words mean right now. Then we're going to find the values. Then we're going to split it and factor by grouping and move to there. Alright, so again, I am working backwards. So that's why it's best to revisit it again after you've had time to practice it, because when you watch it again, it should make more sense, because you will already know where we're going with all this. So the factoring by grouping part, which is step 4, that's where we're going to start here. Factoring by grouping means that you have 4 terms, and what we're going to do is split it in front of the sign. So copy this problem and split it in front of the sign. You then do GCF factoring on both of those parts. The biggest number I can take out of 9 and 12 is 3. They both have an x. I take the x off. 9 turns into 3. I had 2, took 1 off. Plus 12 divided by 3 is 4. Had 1, took it off. There we go. I will recommend that you always copy the sign. and then we ignore the other side, and we factor the front, or factor the back part. The most I can take out of 6 and 8 is 2. I can't take off an x because 8 does not have an x. I then open a parentheses. 6 divided by 2 is 3 with an x, plus 8 divided by 2 is 4. Now here's what's funny. Both of these have a 3x plus 4, which is typically going to happen. Actually, after a while, you'll trust that you'll get the same thing unless you did something crazy. So we are going to do GCF again and pull off the 3x plus 4. And when you do that, you are left with 3x and plus 2. And that looks just like, if you go back to the beginning of the video, looks just like what we started off with, where you have something times something else. That would be your finishing steps of factoring by grouping. So again, the general idea: split it, factor the front using GCF, factor the back using GCF, pull off the common piece, and then put the other parts into the second parentheses. So I'm not going to cover it up next time. I'm just going to go ahead and work through it and go from there. Again, B, factor by grouping. Biggest number I can take out of these two is 7 and an x because they both have an x. 21 turns into 3 with an x because I had 2 and took 1 off. Copy the sign. 14 divided by 7 is 2 with no x because I had it and took it off. Again, my advice to you is always copy the sign. The most I can take out of 15 and 10 is 5. I cannot take off an x. And again, my advice to you is to always copy this over, because as long as you did it right, it will match. Now you're going to say, well, but that's a negative and that's a positive, but isn't that a negative 5? Negative 5 times positive 3 is negative 15. Negative 5 times negative 2 is positive 10. Again, if you're doing it right, these two will always match. Just do a real quick check after you copy it over to make sure everything makes sense. But after that, we copy what they have in common, and then we put down what is left into the parentheses. 7x minus 5 is left over, and that would be the finishing part of factoring by grouping. The process itself really is not hard, but again, this is the ending part, which means that we have to kind of think about what we do before that. Because we'll continue to use the grouping process, we're going to move on up one step, which was to split the expression. So, split the expression just means that before everything goes, you're going to find out two numbers that you can split this into. Notice that negative 1 and positive 32 add to make positive 31. And so what will happen is, once you know these numbers, you will literally take your 8x squared and keep it, and you'll split this into two numbers, which is minus x, because that's your negative 1x, plus 32x, and then keep your minus 4. So again, that number stays, your middle term will split. Alright, from there, guess what you do? You split it, take off what you can, and go from there. Okay, so again, you would say, what can I take off of 8 and a number? Nothing, but I can take off an x. I can then open a parentheses and get 8x minus, well, since nothing's left, 1. Copy the sign. The most I can take out of 32 and 4 is 4. And guess what? I'm going to be left with 8x minus 1, because that should go over. And again, notice how this finishes off. Copy this part. Copy that part. And it's done. But this is the focus of what we're looking at on the split the expression. Again, don't worry about where those numbers come from. We will get to that. That's in the first two steps. But again, the key idea is, once you know the numbers, you are splitting the middle term into two things with both an x on it, or whatever that term on it is, and then that's what sets us up to factor by grouping. Again, if you look at this, negative 4, negative 9 both make negative 13. So I would split this to be x squared minus 4x minus 9x plus 36. And again, think about it. The only reason why this would be illegal is if I change the value of it. But what does negative x and positive 32x make? They make positive 31x, which means that all I did was give it a facelift. I rewrote it with 4 terms, but it's still equivalent to the original. Just like here, x squared is still x squared, 36 is still 36. These two still make negative 13x. So this is still equivalent, but it's in the form we like now because I can split it. and I can take off an x and be left with x minus 4. Here again, all I have is x I can take off, 1 left over, 4 left over, copy the symbol. The big number that comes out of 9 and 36 is 9. Again, I would just copy my first parentheses over and do a real quick check. Yes, that's negative. Yes, that's positive. X minus 4, x minus 9. But again, this is a key step that we're talking about for splitting. But notice how we've wrapped it up with our grouping step and how everything's going to go. Alright. If you're grasping this a bit more, then you're in great shape. The last two steps will be taught together. Part of these steps was already covered in the last two lessons, so let's just go ahead and get to it. Remember, I told you that we were learning to do a step that was important. Well, here we are. Translate the expression and find the value. So again, 1 and 2 is going to go together. We're doing both of those things together. Remember that standard form of quadratic equation is ax squared plus bx plus c. Our translation format will remain the same. So what you have is, and you want to copy this down because this is where you get your combination from. You want a combination that multiplies to be whatever a times c is and adds to b whatever b is, including the sign. Once you have the translation, use the factors to find the values, and that's where you go from. So like I said, this was taught in the last section, maybe the last couple sections or whatever, but it should have been in there in your homework somewhere where you had to practice it. So now we're going to go ahead and practice the first two steps before putting it all together. I believe we have some of these to do. Yes, we do. So we're not going to work A and B out completely, but we will start later on. So this is just working on A and B. Here we are looking for numbers that multiply to B, 9 times 8, which is 72, and add to B this number, which is negative 27. And if you remember, we put down 72, 3 times 24, 4 times 18, yeah, 5, no, 6 times 12, 7, nope, 8 times 9, but again, that was part of that lesson. The fact that it's negative 27 means my big side is negative. The fact that it makes a positive 72 means the signs have to be the same. Remember, that was from the last part. And which one of these make negative 27 would be those two numbers, which means I'm just going to explain it to you that now you would put 9x squared minus 3x minus 24x plus 8 and continue the steps. On the next one, we are looking for numbers that multiply to be 5 times negative 8, which is negative 40, and add to be negative 18. So again, multiplies to be negative 40, so I just do my 40, 1 times 40, 2 times 20, 4 times 10, 5 times 8, 6, 7, nope, that's it. And so from there, because it makes negative 18, or adds to make negative 18, means my big side has to be negative. Because it makes a negative 40, it means the signs have to be different through multiplication. And which one makes 18 would be, I believe, this here. And so what you would do is 5x squared plus 2x minus 20x minus 8, and do the rest of the work that is there. Now again, it seems like a lot, but that is why I wanted to help you get ready for it. But again, once you start to practice it, once you actually fight it and give all your effort to it, I think you'll find that it's not as bad as what it seems. It's just a process you have to practice. So hopefully you've taken solid notes and replayed portions to gain a solid understanding of the topics. If not, now is a good time to revisit it. If anything you're still fuzzy on, because pretty much we're going to put everything together with trick questions. So you don't have to be perfect anywhere, but you need to at least have a general idea what's going on, because again, this is where we put the Algebra 2, which is your 6-weight work, into factoring. So if we were asked to solve this, the way I discussed, this should be x squared, by the way, equals 7x minus 10. The way I discuss solving, when you solve something like 5x plus 2 equals, let's say, 12, our job is to send everything away from x and find our answer. The thing about it when you have a x squared is I like to think about it like an elephant on a boat. So I have a boat here, which is not going to be great. There's water, and there's a big old elephant on the boat. Sorry, I don't know how to draw an elephant. And there's a bunch of little things over here. Well, what's going to happen if there's an elephant on the boat, although it looks like a dog or some kind of sick dog? Anyway, if there's an elephant here, this boat is going to tip, which means everything over here is going to tumble to that side. So the way I discuss it is anytime you don't have a regular x, if it's an x squared, x to the third, x to the fourth, anything like that, the first thing you have to do before you can solve is move everything over. And so the first thing we're going to do is move everything over to make sure it equals 0. So we end up with x squared minus 7x plus 10 equals 0. In other words, if there's nothing over there, just switch the sign on the number as you send it to the other side. From there now, we need to factor this. And so in that case, we are going to find the numbers first. So numbers that multiply to be 10 and add to be negative 7. Those numbers are, let's see, 1 times 10, 2 times 5. This means my big side has to be negative. The fact that it multiplies to be a positive means the signs are the same. Means those are my numbers. And so I am now going to take and put x squared minus 2x minus 5x plus 10 equals 0. Just can't forget the equals 0. Remember, those two make negative 7, so we're still equivalent. Split. The only thing I can take out of here is an x, being left with x minus 2. Copy the sign. The most I can take out of that is a 5. Again, copy this over. Now we take off the common part. Again, GCF. And we take off the part that was on the outside. And this just looks just like it did in the beginning, where if this times that equals 0, then we put x minus 2 equals 0, or x minus 5 equals 0, which means that x is 2, or x equals 5. Whew. So looking at that, 2 squared is 4. 7 times 2 is 14 minus 10, which is 4. 5 squared is 25. 7 times 5 is 35. Minus 10 is your 25. So again, there's your proof. It worked. I'm not going to do B completely because I see that we're at the 22-minute mark, which is a long video, and we have even more to do. I will quickly, though, show you what you need to do. Remember that if there's an x squared, you want everything to tumble over to the x squared side. 5x is already here, but this 6 needs to move. And so what we would do is move our 6 by switching the sign on it, turning this to 21x squared minus 5x minus 6 equals 0. Again, not going all the way through, but just to show you. Multiplies to be negative 126, adds to be negative 5. Again, find the numbers and do the work, and that would be what you would do there. Alright, you're going to get practice on this, trust me. Your assignment's waiting for you. C, though, is different, because the first thing you notice on C is that all these have a x on them, which means I can actually factor off an x. And so now I want to factor the inside and kind of ignore the x, but again, that would be numbers that multiply to be 210, add to be negative 73. I'm just going to use my calculator and do it the old-fashioned way here. So 210 divided by 1 obviously is not it. 2 and 105 obviously don't make 73 no matter if I add or subtract. So again, I'm just kind of looking for these things and for numbers that make what I need. So 210 divided by 3. Look at that. 3 and 70 I believe make 73. So let's see. If it's 3 and 70, that would be negative. That would be negative. Do these two make negative 73? Yes, they do. Those are my numbers. So again, you're going to go x times, and this is going to be 21x squared minus 3x minus 70x plus 10 equals 0. So I'm going to ignore that for a moment and do my work here. Splitting it, taking off my 3x, because the biggest number for 21 and 3 is 3. X comes off, leaving me 7x minus 1, because 3 divided by 3 is 1. Copy the sign. The biggest number I can take out here is 10. And again, copy your 7x minus 1. Just do a real quick check. Negative 70, positive 10. And so the ending part should be x, which is still here, times 7x minus 1 times 3x minus 10 equals 0, which means in the end you have x equals 0, you have 7 minus 1 equals 0, you have 3x minus 10 equals 0. That's already done. This is now done. And that is also now done. And that would be your 3 solutions. How do I know it should be 3 solutions? Because it says x to the third. How I know I should have two solutions? Because the highest power or the degree is 2. Alright? Sometimes you're asked to work backwards, as you will be on today. You want a quadratic equation with roots of -3 and 11. Remember that roots are zeros or solutions. So in other words, your roots are -3 and 11. I'm going to give you a hint here. If the root is -3, that means it's probably going to be x plus 3, right? Because I would put x plus 3 equals 0, which means that I would do that work to get x equals -3. If the root is 11, then it should be the opposite, which means x minus 11. Which means what I'm doing here is actually creating the quadratic equation, which means I'm just doing the distributive property. And that is what they're looking for when they say create a quadratic equation with roots of -3 and 0. Actually, it's not that part. It would be y equals x squared minus 8x minus 33 would be the right way. Same thing here. Create a quadratic equation with roots of 5 and 16. If the root, which is solutions, is 5 and 16, that means one of your numbers should be x minus 5. The other one should be x minus 16. And so you just distribute x squared minus 16x minus 5x plus 80, which means that your final answer would be y equals x squared minus 21x plus 80. And that would be what you're doing there. Alright. Almost done. The very last thing you're going to see on your homework is stuff that kind of pushes your ability to think a little bit, because of course that's what we're here for. And so it'll say write the equation with the roots of this and this that passes through this point. And so the first thing you want to do is use this part here. So we of course want to use the x plus 3, and we want to use the x minus 7. Alright. But there is a number that would actually be out in front. We just don't know what that number is. We also know that when you do this, that the answer should be 0. Again, if this was in factored form, if -3 was your root, that would be a factor. If 7 was a root, that would be a factor. But there's a number out here we don't know about that we're looking for. And so the first thing you have to do, again, please make sure you take good notes, is you have to solve this. And so we end up with, we take the points, sorry. So we do I remember this? I did this 2 weeks ago. Let's see. So, oh no, we want to multiply it out, that's right. So we end up with, forget your a, it'll be a times x squared minus 7x plus 3x minus 21 equals 0, which means it's a times x squared minus 4x minus 21 equals 0, which means that we are looking for ax squared minus 4ax, remember that's an a, minus 21a equals 0. Okay, so now we're at a point to where we will plug in our point. Actually, that should be a y, because it is the formula. So when we do this, we plug in 16. Of course, that's going to be what? 16 squared, which is 256. So again, 16 squared is 256. I'm going to put this over here. 256a. If I put a negative 16 here, again, I'm plugging in the point. That means that we end up with negative 4 times negative 16, which is 64, and then it'd be positive, so plus 64a. And then that negative 21a is going to stay the same, and that should equal y, which in this case is 598. Putting all that together, 256 plus 64 minus 21. Ooh, that works very well. You get 299a equals 598, which means in the end you divide by 299. Wow. 598 divided by 299 is 2. And so in the end your formula is 2a squared minus 4 times 2 would be 8a minus 21 times 2 would be 42 equals y, or something like that along those lines. Yes, I did it. I put it there in front of you. Whew. Now the last one to wrap up the day. 30 minutes. Find the quadratic formula that passes through these 3 points. 3 points, 3 equations, 3 letters. What are our letters? Ax squared plus bx plus c equals y, or y equals ax squared plus bx plus c. And so we are going to create 3 formulas. First off, we're going to plug in 0. 0 for x means it's 0 times a, which means 0 plus 0 plus c, which we don't know, equals y, which is 3. Looking at that carefully, I think that tells me what c is. Again, 0 and 0 and c just means that c is equal to 3. That helps. We're now going to plug this one in. This would be 4a, I believe, right? Because x squared would be 2 squared would be 4. This is x again, so that would be plus 2b plus c equals y, which in this case is 13. This has a use in just a second. And then the third one we're going to do, plug in x for 4, so that would be 16a plus 4b plus c equals y, which is 7. But here's the good news. There are 3 variables, but if you remember chapter 3, 3 variables means we need 3 pieces of equipment or of information, and we have that because we know that c is 3. So this actually is 4a plus 2b plus 3 equals 13, which means when you subtract that, 4a plus 2b is equal to 10. Same thing over here, 16a plus 4b plus 3 equals 7, which means 16a plus 4b equals 4. Guess what we do with these? If you remember your test from last time, you stack them up. I think it'll be easier to make my b's match, so I'm going to double the top. I'm going to switch my bottom row. Again, I'm not discussing this because we've already done this. Negative 8a, that's gone, equals 16. Just making sure that's right. Yes, it is. Therefore, a is negative 2. Take that negative 2, plug it back into one of my other ones, and you get your last answer. 4 times negative 2 plus 2b equals 10. Negative 8 plus 2b equals 10. Add your 8, 2b equals 18. Divide by 2, and b is equal to 9, which means that my formula in the end is negative 2x squared plus 9x plus 3 equals y. So yes, have a lot of fun with this thing. This is where we've been going all this time, which is why I slowed it down, so you actually have 2 lessons in one. You have the fact that you have to learn how to factor, and then you have those test problems that you need to get ready for. Outside of that, like I said, it's going to be tough. This is 6 weight, and you do need to have some challenge added to it. So best of luck with doing this. Make sure if you ask me for help that you send me a picture of your work so that I can assess what you did and try to find your error. But do not send me a question that says I don't know how to do it, or can you help me with number 5. if you're not doing any work on this, it means that you don't know enough and that you need to kind of get at least an idea of where to start before I can kind of make a difference. But other than that, like I said, good luck today.